The ultimate aim is always to prevent accidents, prevent people from getting hurt, and prevent deaths. Most of the equipment that we have, they don't really take care of safety from the start, at the very start, at the design stage. So that's where I think engineers play an important role. This isn't the age of IQ anymore. Artificial intelligence will provide that IQ. Engineers should be there every step of the way.
Hi everyone, welcome back to the OSH Insights podcast, tailored to the safety professionals in Asia. So far, we've looked at topics like heat resilience and performance and the aspects of psychosocial support at the workplace. But what about engineers this time around? In this episode of the podcast, we are looking into how engineers play an impactful role in occupational safety and health, as well as the technologies that may or may not replace engineers as a whole. To tell us a little bit more about this, we've invited the Director of Occupational Safety and Health Division, Major Hazards Department, Ministry of Manpower, Ms. Jamie Lim, to join the podcast. Now, before we get to our chat with Jamie, I've got a short message to share. The region's leading exhibition for all aspects of safety, security, and health at work, Occupational Safety and Health Asia 2026, will be held from 9th to 11th September 2026, Hall C, Marina Bay Sands Expo. Visitor registration is now open, so head over to osha-singapore.com and subscribe to our e-newsletter to get the latest updates and exhibition highlights. And now, on to the podcast. Hey, hi Jamie, welcome to the OSH Insights podcast.
Yeah, thanks for having me, Edric.
Okay, I'm gonna get this out there right now. You're double hatting, okay? You're the director in the Occupational Safety and Health Division, Ministry of Manpower, looking after the energy and chemical industry, occupational hygiene, lifting equipment, and pressure vessels. You're also a chartered engineer and a council member in the Institution of Engineers Singapore. So I gotta ask this, right? What exactly do you do then? Tell me a bit more.
Okay, so I currently double head, you're right. Two departments in the Occupational Safety and Health Division. One is a Major Hazards Department. Sounds a bit scary, but we look after oil and gas and energy companies, make sure that they have a good system in place, what we call a safety case regime. The other department looks after specialist areas, so like occupational hygiene and as well as medicine, and the other one looks at lifting equipment and pressure vessels. So these are my day jobs. And as part of my career growth, I sought certification. So I've become a chartered member under the Institution of Chemical Engineers that's based in the UK. And I'm also run for election in the local IES, Institution of Engineers Singapore, and I have gotten elected for this term.
Oh, congratulations.
Yeah, thank you.
Very interesting that you brought that up because it's a great segue to the first question I wanted to ask you about certification, right? First things first, engineers, we all know that engineers are built. It's in their DNA to solve problems.
Yes.
Okay. So two questions to start with. What exactly is the problem to solve when it comes to OSH? And at what stage do you think engineers really come into play? Because there's prevention, there's the maintenance, and there's the post-mortem, if you will.
Yeah. So today we're talking about workplace safety and health, and the ultimate aim is always to prevent accidents, prevent people from getting hurt, and prevent deaths. So engineers can play an important role from the whole life cycle of an equipment or process. Engineers should be there every step of the way. So we can look at the whole process of getting a product or chemical done and how do we do it safely. And when people work along these steps, they are able to produce the outcome and in a probably a profitable way for the company and in a safe manner. So what I think now is most of the equipment that we have, they don't really take care of safety from the start, at the very start, at the design stage. There may be some, but maybe along the way, there could be improvements done to it. So that's where I think engineers play an important role. We not only have to look at the mechanism, how to get it out or how to get the chemical product out, but also how people interact with it. The engineering discipline, I'm grateful for engineering because it has given me a very good base foundation. And looking at the things that I cover today, I'm by training an environmental engineer. I don't really do that now, but that has given me the base. So I went on to look at chemicals and now occupational hygiene as well as lifting equipment. So that base has been good in providing a framework, and I urge all engineers to do the same. So with that framework, apply it to the workplace, equipment, processes, and then interject it, overlay it with how people interact and then get the product or the service or whatever out of it. Yeah, so that is the problem that we need to solve now. At the moment, maybe we are a bit too focused on hardware, or maybe the software bit, like how people view the job, the task, step by step. That part can be enhanced a bit more, which may not be taught in our engineering courses in university right now.
That's really great that you bring that up, because we're going to circle back to the software part of things when we go into technology later on in this conversation. Most of the time when we talk about engineering safety, we always look at PE certification. Do you think that that's the only certification out there? If for business leaders to understand, what more should we look into to get a wider and safer working environment?
I guess if it's from a business leader or top management's point of view, they may not have the engineering knowledge. So it's easier to get a certification, buy services, get somebody credible, trustworthy to help endorse a certain product or process. So that is one way that we can look at it. But beyond that, I think everyone has a role to play. So in a workplace, not only bosses, middle managers, workers, we should all play our part. So if we just say that, okay, we just get a PE certification, that's the easy way out. But what if the boss says, hey, I want to get somebody credible, but I also want somebody in the company to be responsible to take a look that whatever that the PE certified is indeed suitable for us in our context, because everybody's work environment is different, the things we do different, the different forms and how we get things done around here may be different from place to place. So while we want to have PE certification, but there should also some ownership, some responsibility that comes from within the company, the workplace, then it will make it be much safer.
Oh, that's very interesting. Especially like earlier on, you mentioned that engineers should get involved from the very beginning, from the design stage in itself, right? Do you think that this is a conversation that actually happens often, or is it, and pardon me for saying this, but perhaps it might be unlike an engineer to actually raise their hand and say that, hey, I want to take this on. So give me your take on this.
I think the way that society runs is always what's in it for me. Yeah. And sometimes we get a bit short-sighted. We don't see the longer term. And that's pretty common and normal, actually. So it doesn't mean that it's wrong to take this approach because you're paid by a certain task or a certain project. But if all of us just make a little bit of effort to say, hey, maybe we can look out for just one other stakeholder or one other person. And if everybody does that, I think it'll be a much better place. And also, I'm speaking from a very altruistic point of view. It may not be practical, especially when pressures on the timeline, there's impending liability if I don't finish this project on time, which is very real. So everybody wants to deliver on time, then otherwise the penalty comes. Then I think all these may cause certain compensation in other ways, which may not be a longer term gain overall.
That is true.
Yeah, so while we do also have to look at a longer term, but sometimes the shorter term pressures will override. It's only human. I'm not saying that it's wrong, but maybe everyone can just extend a little bit to think a bit further. So in the work of safety, if I may use a similar analogy, is when we look at risk assessment, we want to identify hazards. And that is where we also have to think a bit more, what else did we miss out? What are the gaps we didn't cover? So if everybody does that kind of thinking, extending it a bit more to others around them, it may be better in the future for everyone. My vision is hopefully it will be a day where everybody has they recognize the dependencies on each other. Like for example, I'm a safety officer, but I also need the business owner to play their part. There are functional leads that also control the operations, the equipment. And if they buy into me and we understand each other's difficulties and come to a landing where everybody works out well, I think that's a better place for all of us. If we can come to that and realize, have that partnership, it'll be good.
So I would foresee that there's going to be a curriculum sooner or later that you'll probably have to include that in school as well. It's like engineering business management almost.
Communications, networking, overcoming challenges, making sure that we understand each other. So I think comms is a very basic thing that we should learn. There is some little module that I did last time in undergraduate school, but it's just overshadowed by all the engineering math and all the fluid dynamics. However, with AI coming up, I think there's a place for us to focus a bit more on the human connections. So AI can do very first draft, first cut of certain calculations. And then when we put them into a system together, then the humans can talk to humans to say, hey, how is this? Do you think there's any issue with this? Or do you think there are some overlaps that we have failed to look out for, interdependencies that we should have considered but we didn't? Yeah, and the comms can come. We can have more time to do this kind of meaningful communications, conversations.
That is true. That is true. And I love that you're bringing this up once again, because it really does translate into the next point, which is technology. And again, I have to address this elephant in the room, which is we are in such a fortunate space where we have all the technology in the world that is predictive, almost preventive, and it can tell you so much more that you may not have seen with your own eyes, right? And even do the assessment for you. But yet, accidents are still happening. Safety breaches are still happening. So if technology is really working, why isn't it predicting these things? Where do you think we're lagging here?
I think we are in the intermediate stage. We have some legacies that didn't have all these sensors, interlocks that can raise alarms or stop maybe the process from going on, stop the machine. So we have this overlay of older stage versus the newer stage. And there are people who are workers who have not adapted to the new technology, or they are not able to get a hold of how it can help them. And also, we also have the younger generation who are very savvy and they know exactly what to do. So the communications, the different interlays between the legacy and the new, I think that's causing the problem now. Yeah.
Do you think that it's really about the age and skill gap that's causing this?
That's probably part of the reason. But what I'm saying is there are different stages, different phases of eras of equipment. So till we get to a stage where we are very interconnected, the whole system is able to predict such that it can even be autonomous, or if there is very little human intervention, then that's probably where we're going to be in a much safer area. But now we still have the human-machine interface, and how that interface, the extent of it varies. So it can be very manual to very halfway hybrid, or it can until we get to a very system integrated autonomous stage. I don't think we'll reap the benefits of tech so soon yet.
Interesting that you bring this up. I mean, with the tech that we have, are there certain technologies so far that have caught your eye, that you go, oh, wow, this is really cutting edge stuff?
In my job, what we want is something that's practical and easy to implement. And then people who use it, they understand it. So there was one comes to mind. There was a case where the worker failed to hook on his harness. He was erecting a scaffold. There was actually a place where he is supposed to latch on. He forgot to, and in the process, where he was standing on gave way, and he fell into the water below. Yeah, so he drowned to death. After that, there was a very quick fix that the company did. So what they did was to attach sensors on the hook as well as on the latch where it's supposed to hook on his harness. And this tie-in point, right, once it's connected, the sensors are in close proximity, it sends a signal back to an iPad of the supervisor to say that, yeah, the guy is hooked on, he's able to continue with his work. And if he doesn't get hooked on, then there will be an alert. So it's a very simple, cheap sensor in proximity, and it sends a signal to an iPad. That caught my attention because at that time, to me, sensors were difficult to install because you need to make sure that they are in line with whatever system that it has. Like if you put a sensor on a machine, you must make sure the machine's PLC must be able to take in the readings, the inputs, outputs of the sensor. But in this case, no, it's just because of our own manual action, the sensor reads in proximity and sends a signal. Yeah, so that kind of changed my concept of how tech can actually help us. So that was the start. So now, as we learn more about how AI digitalization can help us, is there a way that we can make it even better, such that first is people are aided with this, such sensors, but the next step eventually is would people be able to do this remotely, or it can be even autonomous. I don't have to control from a comfort of my control room in an air condition somewhere, but it can be carried out and I just need to troubleshoot.
What do you think it's an industry right now, right? That is very high hazard, but still running very low tech in terms of safety?
I think the construction, marine, as well as some manufacturing, they are still quite manual.
Traditional industry, huh?
Yes.
Interesting.
Yes.
Why do you think so, though?
Because we still rely on manual labor to get things done. Transportation from place to place, painting, fixing up things, or assembling equipment. Food production also sometimes is very manual. Yeah, so there are some that have automated, but some still use like mixers and they have people pouring and stuff like that. So these are the ones that I think can improve in terms of the tech.
It's an interesting thought, that's for sure. Because at the end of the day, right, it's more of identifying which of these areas could have more room for innovation. And I suppose that safety leaders, right, in those industries should be able to open up their minds a little bit more and go, hey, where can we innovate here? Even if it means, let's say, for example, the back of the lorry, we should have the additional step ladders. We have sensors, false sensors here and there. I mean, like what you're talking about, even the tethers. Paul, the safety reflective vests could already be embedded with these sensors already. So you know whether or not, they are safe in that sense. I mean, these things could be easily implemented and all it requires is just a little bit of innovation.
Yes.
Yeah,
and also the aim, the intended purpose must be clear. So you can have a lot of sensors on the worker, but what does it do? Yeah, and what alarm does it trigger?
Yes.
Yeah, so there may be certain rules that you have to set and be very clear about it. Then you implement the sensors. Otherwise, it's just redundant, it's an annoyance, and maybe some fatigue as well. So workers will not want to wear the vest.
Sounds like this comes from a place of experience.
Yes, that's where the human mindset comes in. So you want to have good control measures, but you also have to know the psyche of the worker. If it helps him to do the job better, sure, he will apply it. But if it increases the time or adds more step, then probably he will just bypass it when it's crunch time.
Really interesting. Thanks so much for sharing that. We're gonna try to switch gears here a little bit. And earlier on, you talked about the age groups. We have quite a number of engineers who are relatively senior, and you've got a new wave of engineers that have also come in, right, who are perhaps more tech savvy. I did some reading on this, and some of the information here suggests that in Singapore, younger professionals are in their 20s to 30s. They are active in tech and aerospace. Yet earlier on, we talked about traditional sectors, right? Manufacturing, construction, so on and so forth. You're going to see more experienced staff, the veterans of the industry, if you will, right? So obviously the younger talent, right, would want to join I would think, sexier or trendier industry vertical. So what does this mean for more traditional yet essential industries such as manufacturing? Where are the engineers really going to go?
So I did a bit of check on this as well. The number of engineering graduates from university every year, it's about 4,002 to 4,004 for the past 10 years. It hasn't shrunk. It has been quite steady. If I looked at the non-engineering disciplines, it has been creeping up, especially the business and finance sectors. So that's one set of stats to look at. The other one is in terms of after graduation, actually engineers also do secure a full-time job 90% of the time, similar to business and finance graduates. Yeah, but what it drops off is it will drop off slightly. Those who retain in an engineering role, a full-time role, it drops off to 80%. Yeah. So I think there are a lot of contract jobs out there for engineering compared to finance and business. So they are more full-time. But engineering, as the projects come and go, it turns less of a full-time nature towards a more contract-based. So that could be less attractive because there's some uncertainty and the stability may not be there. So these are just some of my guesses, trying to take a jab at what is going on out there and what graduates are thinking about. And of course, with the traditional versus the now more trendy AI, data analytics, computer science, engineering, that kind of thing, I'm sure that commands more money, more salary. So the younger generation, the younger engineers would tend to pivot towards where the money is. So that's also a natural thing.
Okay.
And coupled that with some of my experience interacting with engineers, most of them are more experienced. So I don't see as many younger engineers or new graduates joining like seminars or talks or networking sessions. So that number has come down. So I'm a bit worried because where are the younger ones? So they're probably off at like data and stuff like that, or they don't find that this is attractive. I'm not sure. So I hope through my role in IES, I can attract or understand where's the issue and to see how we can continue this engineering profile as we move along.
Okay.
Yeah.
I think that really is the question. Like, what do you think it's going to take to get engineering, a bit more of a spotlight again? Because look, we're here talking about workplace safety and all that. And again, if the big issue is that engineers need to be part of the design phase as well, that means this sounds like a systemic issue that needs to actually be solved.
Yeah, I guess maybe engineers are too direct. We don't know how to market ourselves. Maybe better comms and marketing will help to bring in the younger ones and to tell them, hey, you can make a difference. I think that will sell. And you can make a difference. You can change how workplace safety and health is. Have more fancy systemic views with the inject of AI, data and all that. So I think we need to up the game a bit in the comms area.
That sounds like your campaign trail. Very good. It really does. So you should have looked into your camera and just go, you can make that difference. You should. Yeah, you can make that difference.
You can make a difference.
Become an engineer. So we've talked about the technology bit. We've also talked about the engineers not filling those roles. Now I'm going to turn this around. With the technology that we have right now, does that also mean that there will be less engineers because we have more prompt engineers now?
I would think no, because if anything goes wrong, you need to troubleshoot, you need to repair, you need to maintain. Without the basic engineering knowledge, you can't do it.
It's not something that
No.
AI will be able to cover, will it?
I don't think so. Especially when there are systems like system A integrating with system B, then it's the creation of the human. What would the AI know? The AI will only know system A alone or system B alone. They won't know how it will interact with each other. That's where the human comes in. So and also the creativity in solving problems, that will also come from the human. So without that fundamental knowledge, you cannot have that spark.
Sounds like there's a market for, there's these things called virtual assistants, right? I wonder whether there's such thing as a virtual engineer that you just call on a speed dial and you just have them like 3 times a week in the office or something.
I'm sure there is an engineering assistant already. I just had Claude Pro over the weekend. So when you start up, they will ask you what job you're in. And in engineering, there are a lot of assistants there already. Yeah. Wow. It's available as a plugin.
Okay. So then I got to ask you, does that really make you, keep you on your toes, or how are you leveraging on such a program now?
I'm using it to do first cut materials or some solutions. So it helps me either trawl references, what are the latest updates, like summarize and let me know what are the latest trends for battery fires. Yeah, what are the ways to mitigate? So it helps me a lot instead of trawling through data upon data, references upon references, and many websites. It can come up with a very neat outline, and then whatever I'm interested in, I can just dive deeper. So it saves me a lot of time. And with the time saved, I can go on to do more meaningful work, have better conversations, ask better questions, for example.
Yes.
Yeah, so that's how I'm leveraging on all this AI now.
Okay, that's really interesting. So it's great to hear that AI is not going to replace the engineer, and there is definitely a need to increase the output from schools and also change the curriculum almost, right, to prepare them for that. This is a bit of a futuristic question. What do you think leaders should know, that will prepare themselves for the next 5 to 10 years, assuming they're not retired, and what they should expect from the next generation of engineers?
For leaders, I think we have to move away from focusing on the individual. A good leader, I think, will make sure that the team is able to deliver. So it's not contingent on one person. Yeah. So it goes back to my earlier point when I talk about everyone in the workplace has a part to play. And if we all start looking out for one another, it will be a safer workplace. So leaders must recognize that this isn't the age of IQ anymore. Artificial intelligence will provide that IQ. But what is important is the network of the people. How do they band together to make use of the AI, improve things, create more solutions that are innovative, and that should be something that I think leaders in workplace safety and health should look out for. Yeah. And as for the younger generation, I think we should help them remain adaptable, resilient. In this day and age, it's not about knowing everything. So same logic principle applies. It's not about knowing everything, but it's how do we react correctly to solve problems.
That's very interesting, because that also brings up that question in terms of how we approach things, our mindset, and even cultural differences between the older engineers and I think the new engineers that will come up. I can't really imagine what the archetype of a Gen Z engineer is going to be. I'd love to hear what your take is going to be on this.
I think a serious Gen Z engineer will be someone who wants to overhaul and make things even better. So create something, a totally new system or something that's based on data, backed by science, and integrated with AI. And with it will increase productivity because you only need like a small team of engineers to run the entire workplace, probably. So I think that will be my vision of a Gen Z engineer. Somebody who can speak with people of different ages and yet help them with systems, automation, and AI.
Wow, that is a tall order. So, well, your campaign trail starts today to get things started and changed in school. Okay, so I think the challenge right now is also there's a gap right now whereby we don't have enough talent and we're trying to fill that up. What do you think the challenge is in terms of how we can attract, in terms of businesses? How do we open ourselves up to attract more engineers, a younger talent, and what do you think they should do to help?
I had a conversation with my friend last week, and we were talking about our kids. It seems like a digress, but I assure you it's not. And we were talking about our kids because they'll say like, what's in it for me? And she explained, yeah, it's because when they were growing up, you have to do so well for your PSLE, and then I'll reward you with this, like either a trip or you want to buy a computer game. So they have been wired since young to react this way. It's a cause and effect. So in a way, we concluded that it's our own doing that we caused them to be like this. But I guess we don't take it in a negative way. Maybe we should use this to our advantage to say that, if you join this profession, you could get something out of it. You can make a huge difference. You can have 0 fatalities in workplaces, something like that. So to attract them, to say that this is the tangible outcome you can reach if you join this profession. Would you like to, take this noble cause? help save lives and protect workers while they're at work. Yeah.
No, it's very interesting that you bring that up because we're coming full circle about the altruistic point of view, and stand on that. At the same time, there also has to be some sort of commercial remuneration for, let's say, for example, zero accidents or innovations. Engineers can be rewarded for of course zero accident, as well as growing new systems, improvements, so on and so forth. If that is the way to bring up the talent, I think that's the way to go. That's for sure. Because right now that seems to be the issue, right? Like, if
Yes.
everybody's going to, like what we talked about, if it's going to be the sexier industries, and then our traditional industries are not going to benefit from those young minds, there has to be something there to bring them back in. Yeah. So yeah, any closing thoughts before we end the podcast?
Yeah, I do. I guess in this line of safety, it's a bit of a thankless job, because if everything goes well, nobody will bother the safety professional, nobody will bother the engineer to fix a problem. But when things go wrong, the undesirable occurs, lives get lost, that's when the attention is on safety. So I guess no news is good news in our line, and we want a smooth ship, smooth sailing, but then through it becomes like quite a non-event, no celebration or things like that. So I guess it's quite a difficult position to be in for safety, but nevertheless, those who are passionate about it will continue to see it beyond just, it's very smooth sailing and a non-event kind of a journey. Yeah, so that's just some thoughts from me at closing.
All right, thank you so much for that. So it's a great conversation that we've had. Now this camera is yours. Feel free to just let everybody know how they can connect with you.
So you can connect with me on LinkedIn. I'm Jamie, and you can also look up the IES, Institution of Engineers Singapore, at their website. We have an ongoing list of courses and events throughout the year. And of course, please join IES as a member. You can find more details at the URL below.
Thanks so much, Jamie, for joining us on the OSH Insights podcast.
Thanks, Edric. Thanks for having me. It was a great conversation.
Thank you very much. Thank you so much for joining us on this episode of the OSH Insights podcast. Now, earlier you heard from Jamie Lim, and some of the key points that really stood out from this conversation was that there is a significant age gap between engineers who are more experienced, as well as the young up-and-coming engineers. In addition to that, technologies and innovations are present and implemented by younger engineers, but they aren't showing up in the traditional industries. One more thing that really fascinated me in this conversation was the archetype of the engineers of the future. It sounds like there are really big shoes to fill, but I do think that there is hope and there is definitely going to be growth in this industry. Now, I hope that you enjoyed that conversation as much as I did. It's time for you to act. Share your thoughts, place them in the comments, and also feel free to refer an industry expert to be on the pod. And of course, for more insights on occupational safety and health, don't forget to subscribe to the OSH Insights podcast. We'll see you at the next episode. Bye, everyone.